It's said that perfectionism is the enemy of good enough. And while I personally think the opposite, regardless, time after time, we've tackled some pretty heavy challenges in this project, and they've all turned out better than good enough. It would appear, though, that custom wipers may have taken the concept of re-engineering to a whole new level. You'd like to think we could have used a system from a donor car, but no! To meet the criteria of a compact, all-stainless design with J-hooks, tapered spindles, retaining nuts, and beauty caps, plus a modern drive system, starting from scratch really was our best bet. Especially when the closest alternative I could find was only available used, and for $100 plus the need to sort out some spindles still, I think we actually made the logical choice. Sure, it would have been great to just reuse the factory system, but we couldn't. And I, for one, intend to drive this thing across country someday, so all our effort will be worth it. Some people did wonder if the aluminum hubs will be stripped out by the stainless spindles over time, but thankfully, the taper is doing the brunt of the work here, and the splines we cut are merely to assist in the same way as factory systems. Keep in mind, the drill press, lathe tailstock, and even harmonic balancer all utilize the awesome properties of a tapered connection. And those carry a bit more substantial torque load than our tiny wipers. So all's good then. And with these external parts taken care of, we just need to sort out the guts. How hard can that be? We have a new motor and some Heim joints, but more than Bluetooth will be needed to connect them, which brings us to captive nuts. Specifically, the ones we've hinted about for the last 2 episodes. Yeah, those ones. They were added to give us some mounting points for our new wiper system, as the original design just had the spindles pass through the sheet metal, clamp in place, and that was it. It worked, but put technically, it was a bit flimsy, and another reason why we couldn't just use parts from a newer car. The other side of this sheet metal is the interior. Nowadays, it isn't. You'll find OEMs put the entire assembly under a plastic panel in the engine bay, which very conveniently keeps noise and moisture out of the cabin. Nice. This was the way our car was made though, and to keep the firewall simple, it's how it's going to stay. We will be relying on the connection to be watertight, but relax, Lucas designed it, I'm sure it'll be fine. At least it's not electronic. Anyway, I digress. To beef up this design, our new crossbar, which directly ties the 2 spindles together, will get some brackets that bolt up to these points and should take most of the load off the bodywork. Before we can build them though, we must first finalize the tube by putting a small bend in it, so each spindle will point in a slightly different direction. It's subtle and mostly hidden away up there now, but as you can just about tell, this was necessary as the passenger spindle lives close to the center of the car, while the driver one is on a downward slope, meaning the 2 need to point away from each other to keep the angle of the blades correct through their operation. Good. With that done, let's make some brackets. Awesome! We've maintained access to all 3 bolts, and by removing the top 2, the whole assembly can be pulled out from above the blower unit. If the bracket wasn't a separate piece, the entire dash bar, steering column, blower unit, and pedal support bracket would have to be removed to get to the wipers. Not ideal. I'm glad we avoided that hassle then, but before we can push on with the other bracket, we do need to do something about the spindles, because, you know, wipers are generally more effective when they move. those aren't going nowhere. And if you're wondering, the length of these arms was not just determined by throwing darts. The blades need a 103-degree sweep to cover the windshield, and as the spindles move with them, we'll just focus on the arms in question. That's our arm, and it moves 103 degrees. Okay, here to here must equal the total stroke of the motor, which is 41.5 millimeters times 2, or 83 millimeters. To find the length of the arm then, we'll divide this in half to create a right triangle. So now this side is simply the length of the motor arm, and this is 51.5 degrees. You'll note the arm is also the hypotenuse, which, remember from school, should be longer than the other sides. To find it then, let's use an online calculator tool, because we're not in school now and this is how life works. Side A will be the 41.5, and angle A, the 51.5. This gives us an answer of 53 millimeters on the nose, which is precisely how long we've made the arms. Perfect. On that note, if you subscribed now, that would be precisely awesome. Let's next move on to chopping up some tubing that has the same inner and outer diameters as the bronze bushings, so we can define the gap between them and provide an end stop. If we use the entire piece of tubing, we may have difficulties removing the bushings later though. So instead, we're going to cut off just over half their circumference, leaving us with this tiny remainder. It's not much, but it should still be plenty for the bushings to bear against, and we made sure to leave a little clearance when the ends protrude in the lathe. Tossing everything together then, you can just see that little section through the hole in the tubing, and all we need to do now is center the bushings and weld through the hole to lock it in place.
Well, here we have our cardboard windscreen. They're not connected, so they're not perfectly synchronized, but Michael's got left hand, right hand. Just using the lever arms. We could be a Honda. You could be a bus. That's a city bus, isn't it? Yeah, we're on the right track.
There is, if I wiggle down here at all, it's wiggling out there. There is no slop.
Unlike the original system. Now the next step is to put Heim joints in there to do that with one hand, so that you can go.
And ultimately a motor.
And a motor. Yeah, we'll get there next.
But this was the hardest part. So then, let's push on. That is going to be one positive connection, and I can't wait to see it with a motor on there. But after spending a while planning the motor's location, we've tweaked our design a bit and can now return to building the driver's side bracket. that feels so much more solid than the original. And there's your
Wiper motion.
So then we just need a motor to make it do that, which is the next step. That gets most of the design down pat. Awesome. It may be a bit unusual to have the motor and spindles operating at 90 degrees to each other, but if it's good enough for the masters, it's good enough for me. We can now tack the mounting brackets in place and blindly melt the top corners together as well, so the whole thing will become a unit. That's not going anywhere. Fingers crossed it stays together as we pull it out. Well, I knew it was going to be tight, but there it is. I'd say that worked.
Yeah, I would say it worked too.
Good, we must not have completely messed up yet. Before we add any finishing touches to this part though, I've got to show you something else. That is the body of the car flexing. And it's not this point I'm talking about, it's this one. The area the wiper's attached to, and more importantly, the pinch seam that the windshield is held in by. Eek. This edge was never properly supported from factory, but that doesn't mean I'm happy leaving it that way. So let's break out the cardboard. Okay, I'm liking this a lot. Before we test fit this system again though, let's selectively remove a small amount of material to make it easier to install, plus drill a hole to line up with the one in the new bracket. We have specifically left a small gap between the parts, as without it, there's no way the wipers could be installed. But eventually, a basic little spacer will take up the difference and let us bolt things down tight.
Well, you know what I'm saying. I mean,
They're not evenly spaced
they're
because
not
I was
even-
having to go around the unevenly spaced factory welds.
I see. So there is a way of rationalizing it. Yeah.
Oh, it's not my decision.
Okay. Got it.
It's all in. This guy's bolting down through a little spacer. The ends are bolted in to the T-bar. This guy bolting in through there is anchored through rubber, so there is the possibility of a little bit of motion here, but these are pretty stiff. Coming up to the top, the original bezels are holding down the actual spindles. This one's not even fully tight yet. And already, you're not gonna get the idea, but it doesn't move anymore. Before, I could flex it before, and you could see this piece moving relative to this piece. Now, there's nothing.
We've still got access to the hardware even with the linkages in place, and I think all the parts we've made today are looking pretty tidy. So we'll call it a win. We do need to address the material thickness though, as the bushings are designed for sheet that is twice this size, and generally, the rest of the bracket just needs fine-tuning. With that, we've got the entire bespoke wiper system pulled together, and while I never even dreamed we'd do this, I am so pleased with the results. The motor does need to be left off during installation, but it makes the process not only possible, it's easier too. So whatevs. We still got to add some captive nuts to those brackets on the dash bar, but otherwise everything is bolting in beautifully, and short of some glass, a battery, wiring, lock nuts, and building the entire washer system, we're finished here. Yeah, that list was longer than I thought too. Anyway, we'll come back to that later. There's other things to do. Thanks for watching, and a very special thanks to the amazing patrons, supers, donators, and subscribers who help support our shenanigans. If you're interested in helping out, there are links in the description below. Until next time, keep building. We'll catch you later.